Functions: increasing and decreasing intervals, maximums and minimums. Often when analyzing, we want to determine over what intervals the graph is increasing, decreasing, or constant. These intervals are determined by looking at the graph from left to right, and these intervals are always the x values, never the y values. So you can see the increasing goes from left to right, goes uphill, decreasing from left to right goes downhill, and constant just stays flat. And we'll use parentheses on all of our intervals. Brackets are used sometimes in different textbooks, but we're just going to use parentheses. So as we look at this graph from left to right, the line is going uphill, so it's increasing. It starts at x equals -2, and then it goes forever to the right. So the increasing interval is from -2 to infinity, the farthest left to the farthest right. It's only increasing. There is no decreasing interval. As we look at the next graph, from left to right, the line first goes uphill, which is increasing. Then it goes downhill, which is decreasing. So we want to do the intervals. It begins increasing from forever to the left, which is -infinity, and it stops increasing when x is -3. So the interval is from -infinity to -3. Remember, these intervals are x values only, from left to right. Decreasing, it starts decreasing at the top of the hill where x is -3. And it continues decreasing forever to the right, which is infinity. So again, x values from -3 to infinity. Be careful on the decreasing intervals. Because the graph is pointing down on the right, it would be easy to write -3 to -infinity, because you think of down as -infinity. However, up and down are y values. We're using x values, which is left and right. So the graph moving to the right uses positive infinity. Looking from left to right, this graph is a flat horizontal line, so it's constant. It starts on the left at x equals 2 and stops being constant at x equals 5. Then from x equals 5, the graph increases forever to the right. So our intervals are for constant from x equals 2 until x equals 5, and then it increases from x equals 5 until forever to the right. Often we are also interested in high and low points on the graph, maximums and minimums. Heights are y values. Heights are y values. Those are up and down things. We can see that there is a high point, top of a hill, on this graph at -2, 3. So to describe this, we write maximum of y equals 3 at x equals -2. The low point, or the bottom of a valley, is right here at the point 3, -2. So we write the minimum, the low point, minimum of y equals -2 at x equals 3. Write your answer in this form, please. For this problem, the instructions are Part A, find numbers at which f has a relative maximum. What are these relative maxima? So basically they're just asking us to find the maximums, and there are two maximums on this graph, two tops of hills. So we can write maximum of y equals, and at both of those points the y value is 0. So I'm going to write maximum of y equals 0 at x equals 0. So that's the one on the left. And then underneath that I'm going to write y equals 0 at x equals 3. So those are the two high points on the graph. Part B, find numbers at which f has a relative minimum. What are these relative minima? So that's a low point on the graph. That would be just this one spot. And we would write minimum of y equals, so at that low spot the y value is -5, at x equals, and if you go up it's right in between the 1 and the 2, so we'll just say 1.5. So write the y value first, then the x value, because highs and lows are y values. Maximums and minimums are integer values, and therefore it's impossible to determine just by looking at them. The graphs we were just looking at, it was clear exactly where the maximums and minimums are touching. But if it's some decimal value, you can't just look at the graph and figure that out. So the graphing calculator has a feature to find maximums and minimums. So we're going to look at the graph of g of x equals x to the 4th minus 2x cubed minus 11x squared. And we want to put that into the calculator. We first press y equals and then enter in our equation. For an x, it's this button that says x comma t comma theta comma n. The exponent button is over here to the far right. Now with the older calculators, like this one, when you push the exponent button, it just gives the little caret mark and then the number beside it. For newer calculators, it actually puts the exponent up high, just like you would write it. But then you have to push the right arrow to come down from that to continue on. Minus 2x, and then the cubed would be up here, and then again you have to push the right arrow to come back down. So it depends on the age of the calculator. So once you have all of those in, you want to graph it. I usually push zoom and then just choose 6, which is the standard window. Or if you don't see that, you can just push the graph button. And on the standard window, it looks like this. And you can see at the bottom, it looks like some things have been chopped off. So since we can't see all of the graph on the screen, we need to change the window. The window button is here on the top row. If you have a phone app, you might have to search around a little bit for the window button. But push the window button, and we'll change the values in the window to what you see here. The minimum is x minimum is -5, x maximum 5, x scale is 1, y minimum -100, y maximum 25, y scale 1. You never have to worry about anything below the y scale. To save room, usually in instructions when I give you a window, I'll write it in interval notation. So this would mean that the x minimum is -5, the x maximum is 5, the x scale is 1, y minimum, y maximum, and scale. So if I give you a window in this form, I think you can see how you can transfer it into your calculator screen. Now, very important, if you have changed the window, do not hit zoom 6. Because if you do that, it's going to change the window right back to the standard one, and you don't want that. So just push graph. Now we can see everything. We can see all of our maximums. There's one maximum, and there are two minimum values. And we want the calculator to figure those out for us. So let's do the maximum first. and you'll push the second button and the trace button. Now, if you have the Apple app for the calculator, all you have to do is touch the screen at the maximum point. If you hit the right place, it will turn red and it will give you the maximum and you're done. Same thing with the minimums. You'll just touch those minimum spots. It will, if they turn red, you're at the right place and it will give you the minimum values, and you won't have to go through the menu system like I'm about to do. So I'd push second trace, and this is the menu that comes up. If I'm going to find the maximum first, then I would choose option number 4 here. So I would pick maximum. And then it asks you the question left bound. So using your left arrow key, just move your cursor somewhere to the left of that highest point and then hit enter. Then it will say right bound. So you'll move your cursor somewhere to the right of that highest point and hit enter. And then when it says guess, you always just hit enter. So to the left of the highest point, enter. To the right of the highest point, enter. Guess, enter. And it gives us a maximum that looks like this with these E's in it. On the graphing calculator, when you see an E, that means scientific notation. So for this one, where it says x equals negative 1.268 e negative 6, it means negative 1.268 times 10 to the negative 6. Well, if you move the decimal 6 places to the left, that number is so small that we'll just call it 0. Same thing for the y value. If you move the decimal 11 places to the left, that number might as well be 0. So the maximum is at 0, 0. But remember how we write it. Maximum of y equals 0 at x equals 0. So we found the maximum. Now you're just going to repeat those steps to find the minimums. You're going to push second trace, choose minimum, and I'm choosing to find the one on the left. So when you choose minimum, it will ask you to go to the left, hit enter, go to the right, hit enter, and then when it says guess, you hit enter again. So we have a minimum of y equals negative 13.61, let's just round to 2 places, at x equals negative 1.71. And then we need to find the other minimum. So again, you're going to push second trace, choose minimum. Where it says left bound, go to the left, hit enter. When it says right bound, go to the right, hit enter. Enter when it says guess. And we have a minimum of y equals negative 73.32 at x equals 3.21. Now let's put everything from this lesson and the previous lesson into one big problem. We have a graph and we're going to determine those things that listed there alphabetically, starting with the domain. Remember, the domain is all of the x's from the farthest left x to the farthest right x. So looking at this graph, I see that it heads towards the left forever. It continues to the right without any breaks and heads towards the right forever. So the domain would be negative infinity to positive infinity, or all real numbers. Part B, the range. The range is all of the y's, from the lowest y value to the highest y value. The lowest y value, this graph on both ends points down forever. So the lowest y value is negative infinity. The highest the graph ever goes is this highest maximum point, top of the hill, where y is 4. That's as high as that graph ever goes, and it actually runs solidly through 4, so you would need a bracket on the 4. X-intercepts where it crosses the x-axis, that happens at x equals -4 and x equals +4. Part D, y-intercept, that's where it crosses the y-axis, which is at y equals 1. E, intervals on which f is increasing. So as you look from left to right, it starts off increasing, coming from negative infinity. It goes uphill until it hits x, where x is -2. Remember, increasing and decreasing are x values. It's also increasing. It starts uphill when x is 0 and continues uphill until x is 3. So from 0 to 3. It's going uphill. X values for increasing and decreasing. F is decreasing, so it's going downhill from the time x is -2 until the bottom of the hill where x is 0. It's also going downhill from the time x is 3 until forever to the right. So increasing and decreasing, always x values. We're not going to do part G. Let's put H and I together. H and I is asking for maximums, and we have 2. The first maximum, the top of the hill, is when y is 4. So we write maximum of y equals 4, and that happens at x equals -2. There's another one, another top of a hill on the right side. That would be a maximum of y equals 2 at x equals 3. Finally, part J, f of -2. So they've given us an x value, -2, and they want us to find the y value that matches it. When x is -2 on this graph, y is 4.